that's moving fastest, so that's why it's called Mercury. Okay? And then you have Venus, and then you have us, and then you got the red planet Mars, and then you've got
Uranus.
that's a long way out. Jupiter, and then you got Saturn. Now, Pluto, in my mind, Pluto's still a planet. In my mind, once a planet, always a planet. So, what happens, and even if you look at what the Greek word planet comes from, the Greek word planet means wanderer. So, you have like all these fixed constellations, Orion, Sagittarius, whatever, okay? And so what they found is that these points of light would move relative to the fixed constellations. And that's why they were called planets, because they wandered around. So here's the best kind of simulation I can give you. So right now, I look at Isaac, and Isaac is in the constellation Blue Shirt, okay? So if I'm the Earth, and I'm looking at Isaac, I have to judge his position by some things that are in the background that aren't going to move, okay? So look, from my perspective right now, Isaac is in the constellation Blue Shirt, okay? From their perspective, Isaac might be in the constellation Crab, okay? Or in the constellation Purple Shirt, okay? Isaac's position is there, but you're going to judge it differently. I'm just saying, from my perspective, Isaac is in the constellation Blue Shirt. Now, Isaac gets up and he starts to walk. So then he's going to move away from the constellation Blue Shirt, and he's going to go to the constellation Ladder. And then he's going to go to the constellation Glass Barrel on Red Carpet, okay? So he's going to keep moving to my left. Now, at some point, Isaac is going to stop. And he's going to go back towards the constellation Blue Shirt. But then he's going to stop again. And then he's going to keep going forward and eventually end up over here by the constellation Sync. Okay? So he's walking, he goes back, then he goes forward again. Now, one thing I want you to get out of your minds is that this does not happen just in like one night, okay? The planet is still going to rise in the east and go across to the west. That motion is still going to happen. But what's happening is that very subtly, that the position of Isaac, Mars, whatever that planet is, relative to the constellations that are still moving east to west, is going to stop. And this might take like 3 months. It's going to stop. Then it's going to start, relative to that constellation, moving back in the opposite direction. And it's going to stop, and then it's going to start moving forward again. This whole time, when you see it at night, it's still on this trajectory of east to west. So don't look at this and go, oh, Venus is in retrograde. And you can walk out in the night and see Venus go back and forth in the night sky. No, no. It takes a long time for this to happen. But what they had to explain was how it happened, okay? So initially, when you were dealing with a Earth-centered solar system, so they said, here's the Earth, and here's Mars. So what they would do is they would send Mars into this weird thing called an epicycle. Now, you also have to understand, this is well before Newton's works, okay? This is not, oh, Newton has come up with these theories. No, Newton hasn't even made the suit. But it worked. So what they would say is that here is Isaac. Isaac is moving in this direction. Then he's going to stop and he's going to make a loop around one of the lab tables. and then it's gonna come back, and then it's gonna keep moving again. Now, from our perspective and our knowledge of physics, we look and go, that's just jacked up. Because what would have to happen for that suborbit to take place?
Gravity.
Yeah, you would have to have, out of nowhere, a very strong gravitational source that would appear in the middle of the epicycle, pull it into its orbit,
And then release.
make it go around, and then magically disappear.
That'd be pretty cool.
And then it would go back into its normal path. It would be like you guys swinging that rubber stopper around over your head, and then all of a sudden, boom, it does this, and then it goes back to going around you. Weird. But it worked, okay? Don't look at this and go, oh man, epicycles, how jacked up. Adopting the epicycle idea with the geocentric model, because they had all of this data, they had centuries of data. It worked. They could predict when the planets were going to go into retrograde motion. It worked beautifully. But everybody's kind of going, it just seems shaky. You know, everybody thought there should be a simple explanation. So, and I will never ask you, like on the test, the names of these big players. This is just kind of historical background. So, the first one to really come up with a really good model that supported the sun was Nicholas Copernicus. So he was the first one, that's the CUS, that really published a well-written scientific paper that supported the idea that we had a sun-centered solar system. But there's a backstory to it, as often there is in science. Nicholas Copernicus was a Polish monk, and so he kind of worked for the church. And he knew this would create a controversy if it was published. And quite frankly, he didn't want to deal with it. So he wrote this paper that explained the whole basis of a heliocentric solar system. But he said, do not publish this until after my death. I don't want to mess with this. It's a well-written paper, here it is. Don't have it published until after my death. Now, that also was a problem because this is well before the internet and printing presses and everything else. And at the time, Latin was like the international language of science. So there was only a very small number of people that would even be able to access this, okay, let alone read it and understand it. But this was gaining some popularity. So Copernicus, heliocentric. So the next big player that you need is this guy, Tycho Brahe. So
Tico.
if I could go back in time and hang out with like somebody from history, I think I'd hang out with Tycho. So Tycho was a Danish nobleman. And Tycho, number one, he had a really cool handlebar mustache. Jealous of that. Number two, you really can't see it here, but he had a gold nose. He's the gold nose guy. So he was like the original brain scientist. So how he got the gold nose, according to the legend, they took their math very seriously back then. So according to the legend, Tycho Brahe and another nobleman got into an argument over how to solve a mathematical problem. Tempers flared, swords were drawn. In the sword fight, he got his nose cut off. Well, being a Danish nobleman, he couldn't be seen without a nose, so he had a gold nose fashioned, and that's what you see in these pictures. But that isn't the point of the story. So the point of the story is that Tycho, being of Danish nobility, really didn't have a job, but he had access to an island in the North Sea. So he went out and he built this massive, at the time, very high-tech observatory to watch and track the motions of the planets. And he did this for like 20 some odd years. Okay, this was his job. So he had, this is before telescopes too, okay? It was a mechanical way of tracking. So he had all of this data, okay? But he really didn't know what to do with it. He did come up with his own solar system. It was called the Tychonic solar system. and which was a combination of heliocentric and geocentric. So he had some things orbiting the Earth, but he also had some things orbiting the sun. So the next big hitter in this story is Johannes Kepler. So Kepler, this we'll talk about tomorrow, came up with 3 laws of planetary motion. So the intriguing part of Kepler is that Kepler believed that he was put on Earth on a mission from God to find the laws that govern the motions of the planets, okay? But he knew he couldn't live long enough to collect all the data and come up with the formulas. So he needed Tycho's data. So he goes to Tycho. He says, yo, I'm on a mission from God. Can I have your data? Tycho says, after my death, you can have the data. Tycho unfortunately passes away. Kepler shows up, knocks on the castle wall, says, hey, can I have the data? Dane's family says, no, we're gonna hold on to it. So like Mission Impossible, he storms the castle, steals the data, goes back to Germany. We'll take that up tomorrow. I know, it may sound well, but no, you have no.